Section 1.4 is going to involve looking at angles and some postulates. Here's a warm-up from what we worked on so far with segments being congruent using the distance formula and finding the coordinates of a midpoint using the midpoint formula. So why don't you go ahead and try those two questions and see if you are getting them correct. So if you did the questions correctly, the two segments are not congruent because KL is the square root of 85 and MN is the square root of 81, which is equal to 9. So no, they are not congruent segments. If they were, they would have the same length, and those are not the same values. The midpoint, using the midpoint formula, we are taking the average of the x values for the x coordinate and the average of the y values to find the y coordinate, and you can see the midpoint is -11, -2.5 for that coordinate or ordered pair. So in section 1.4, we have some stuff that should be familiar to you and then some new things to look at. So we're going to name and classify angles. We're going to draw and measure angles. So here's where you use your protractor. We're going to find the measures of angles using the angle addition postulate, very similar to segment addition. We're going to talk about congruent angles, again, very similar to congruent segments. And we're going to talk about angle bisectors, and again, very, very similar to segment bisectors. So all these things are just really applying to angles now. So first, let's define an angle. So you already know what an angle is and you're familiar with it, but the formal definition is an angle is two different rays. So we have this ray right here, HR, and we have this ray right here, HS, and those two rays, which are the sides of the angle, they have the same endpoint. And that endpoint right there is called the vertex. When we name an angle, we can name it with one single letter as long as there is only one possible angle and name for that. So we could name this angle H. We can also name it with three letters, but we had to make sure that the vertex is in the middle. So we could also name it angle RHS, and we could also name it angle SHR. Lots of times we have to use three values. If we had another ray drawn into this picture right here, now if we have another letter on this, we would not be able to name that angle H, because we wouldn't know if we were talking about this angle, or the original one we named. So keep that in mind as you go forth naming angles. How many different angles are in this picture below? Well, we have one angle here, we have this angle here, and then we have this larger angle right here. So the number of angles in this picture are 3. So we have 3 angles in that picture. So we're going to name them all. So the first one that I named, the first one with one tick mark, or this is what we call this one tick mark right in here, is angle WAL. And again, I can't name that just angle A because I don't know what I'm referencing. The second angle we drew with 2 tick marks, we could name it angle LAH. Or we could name it angle HAL. And I could have gone back up here and named this angle LAW as well. And then the final angle we need to name is this larger one right here, comprised of the 2 smaller ones. And that is angle WAH, or I could name it HAW. So I'm guessing you're pretty familiar with angles and naming them. So let's talk about classifying them. An acute angle is always an angle that is less than 90 degrees. And there's an example of one, angle H. An obtuse angle is always greater than 90 degrees. A right angle is exactly 90 degrees. And a straight angle is exactly 180 degrees. And again, I think those are things that you are familiar with. So when we look at this straight angle right here, that is always 180 degrees. And we are not going to try to fool you and go, oh, well, this could actually not be 180, it could be 179. We're not going to do that, okay? So keep that in mind, that if you see a line, okay, we are assuming that it is a linear line and a straight angle. So now let's look at reviewing how to measure an angle. So if you are going to measure your angle, what you are going to do is you are going to line up this part of the protractor on your vertex right there. And then this is going to be sort of like your starting point right here for your degrees. And then you are going to go around and measure to where this ray would sort of intersect it. And normally, I would slide that protractor and show you, but this has to be a PDF in order for you to follow along and use it in Notability. So just imagine sliding that over and seeing where this ray right here of the angle, this right here, intersects it. And when I measured this in class, okay, before this was actually 52 degrees. Now, I don't know if that's exactly where I lined that up, but just to give the idea. I know you've done this before, so this is just kind of a review. If your angle is obtuse or the other direction, you still do the same thing. Let me back up 1 second here. Sometimes students get mixed up whether they're supposed to look at the smaller numbers right here or the larger numbers. Well, again, I'm starting from here at 0, 0. Here's 0 degrees right here, and I am moving up. So this is like 0 degrees, and you're moving up, so you're going to use the smaller numbers and count 10, 20, 30, 40, 50, 60. Okay? Doesn't make sense that this would be way over here in the 120s or 30s. So if it's the other direction, now you're going to use the other side. So again, you're going to slide this. Make sure you're lining up this ray right here also with this bottom 0 degree mark. So again, there's our 0 degrees, and we want to measure up to here. So then we're going to figure out where is that on here. And then you're going to measure from 0 all the way over. So now again, this time I'm using 0, 10, 20, 30. I'm going this direction, and I'm using the outer numbers. So this angle ends up to be about 126 degrees when I slide that over and measure. So now let's do the opposite. Let's draw an angle. So now what we need to do is we need to again line up the center of the protractor right here at that vertex of the angle. Again, make sure that this part of the protractor is right on this straight line. So you always start with a straight line with your ruler. Then what you're going to do is you are going to sort of follow this up on your protractor once you slide it over until you get to 67 degrees. And it looks like here is 60, here is 70, here's 65. So 67 would be about right here. So then I would make that mark on my paper, and then I would use a straight edge to draw in that straight line. And I think I might be a little shy of this 67 degree angle without actually being able to slide the protractor over, but that's how you do that skill. And the same thing for a 57 degree angle. I always like to have this protractor lined up on the right side here so that my 0 degrees is right there. But you can do it either way. But now when I am lining this up and making sure my protractor is right on there, now I'm actually going, all the way past around until I get to 157. And here is 0, 10. So again, I'm using these right here. And I'm waiting until I get to 157. So here is where 140 is, 150, 160. So 157 is about right here. So then I would make that mark on my paper and draw in that line. So practice some of those. I think there will be some homework problems to practice for you to work through on that. All right, so let's look at some of the postulates that are related to angles. And one is the angle addition postulate. And this is so similar to segment addition, where with segment addition, we said, hey, if we have this larger segment and we have another point on here, this blue segment right here plus this purple segment right here is going to equal that whole original red segment. And the same is true with angles. So now we're saying, hey, if this ray and this E right here is on the interior of a larger angle, of this larger angle, JOY, again, E is on the interior, then what we can say is that angle JOE, so this is angle JOE right here, plus this other angle EOY is going to equal the larger angle, which is JOY. So now if we actually put values on this, and if I tell you that JOE is 17 degrees, and I tell you that the whole angle right here, the larger angle right there, the whole thing is 95 degrees, so that's this part right in here is 95 degrees, then how do we find this part of the angle that we're missing, which is angle EOY? Well, all we do is we take 95 and we subtract 17, and that gives us 78 degrees. Because we know JOY is 17, and here's another way to write an equation, 17 plus X, the unknown, EOY, but we know it has to equal 98. So you can just solve that equation. So angle addition, if you understood segment addition, you should be it should be an easy transition to go to angle addition. So here's another example using algebra. We're doing the same thing. We're just going to use expressions rather than values. We want to find the value of X here. So to do that, we're going to take the angle measure of CBD, and then we're going to find CBD. So we know that CBD right here, this is 5x. When we add that to ABC, it's going to equal this whole thing, ABD, which is 88 degrees. So all we're going to do is take 10x plus 5x and set it equal to 88. So we have 15x equals 88, and when I divide each side by 15, I get x equals 88 over 15. So that's the value of x, 88 over 15, which if we want to get it, we can either use 88 over 15, or we can go ahead and divide 88 by 15, and that gives us 5.86 repeating. Oops, wrote that in the wrong place here. I'll erase that in a minute. Or if you want to use 5.9, that's fine. But usually if they don't tell us, we usually round to 2 decimal places. But we could also approximate this for simplicity at 5.9. If we do that, then to find CBD, which is 5 times x, we would take 5 times 5.9, or 5.86. Sometimes with angles, we are usually more to the nearest tenth than hundredth because it's hard to see hundredths of angles versus tenths of angles. So now when we, didn't actually finish that problem. So when we multiply 5 times 5.9, that would give us 29.5 degrees. And when I find the measure of angle ABC, I can certainly do the same strategy, which is take 10 times 5.9, which 10 times 5.9 is 59 degrees. Or I certainly could have actually found that by taking the whole angle minus 29.5, the angle that I've already found, and that still gives me 59 degrees. 88, that doesn't seem right. That might give me 59.5. So 88 minus 29.5, which I already found, is 58.5. So kind of, there might have been let's change that there. So depending on how you solve it, you could get slightly different answers. This is end up to be 58.5, and this ended up to be 59. Why the difference? Well, because it has to do with rounding. If you actually use the whole entire decimal place, you will not have that issue. And that's one of the reasons it's really important for you to justify your work and show your work so that we know that you actually got the correct answer. You just did it a slightly different way. And that happens a lot in math. And that's one of the reasons we always are asking you to show your work when necessary. Okay, so here we have another problem where we are using angle addition. But what's different here is they did not give us the whole angle measure right here of the large angle. But what you should understand and recognize that these 3 points all lie in a straight line. So that means that this degree measure right here combined is 180 degrees. This is that straight angle. So we're going to find the value of x by taking the two parts of the angle, 6x plus 4 and 3x plus 5, adding them together and setting it equal to 180. So now we can combine like terms, which gives me 9x plus 9 equals 180. Subtract 9 from each side, and that gives me 9x equals 171. Divide by 9, and I get x equals 19. So I found the value of x, and now I'm going to find the two angles. Make sure you're always paying attention to what angle they're asking for. So MAH is this angle right here. So I'm going to take 6 times 19 plus 4, and that will give me 118 degrees. I could just subtract from 180 right there, or I can take 3 times my value of x and add 5. And that should give me 62 degrees. Either way for that, because we didn't have any rounding on that one. And this is the same kind of thing, only now what they're doing is they're giving you the expression for this whole angle, HOM. So what you know now is HOM is 23x minus 15. So now what's going to happen is we take the two parts, 9x minus 9, added with 8x plus 12, but instead of it equaling like 180 in the last example, it equals another expression. But these should be pretty familiar for you from algebra. So when we combine like terms, we get 17x plus 3 equals 23x minus 15. Now we need to get all the x's on one side, the numbers on the other. So I'm going to choose to keep the x positive. So I am going to subtract 17x, which will give me 6x over here, and I'm going to add 15 on the other side, which is going to give me 18. So now I get a value of x of 3. So I found the value of x, and now it's simply a matter of just plugging them in. I'm going to let you plug those in, and on your own, give that a try. And if you plug them in correctly, you would get 18 degrees and 36 degrees. All right, another thing we're working on is congruent angles. Again, similar to congruent segments, if two segments have the same length, then they are congruent. Here, if two angles have the same measure, then they are congruent. So we have, if the measure of angle K, that's what this little M stands for. That's kind of a scripted, italicized. This means measure So if the measure of angle K is equal to the measure of angle B, then we can say that angle K is congruent. Remember, that symbol is congruent. So it says name the congruent angles in the figure. Well, what you're looking for is they have the same markings. So you can see that these two are marked the same. So what we can say is we can say that angle G is congruent to angle M. We know that because they both have two little swooshes or tick marks on them. Okay, now if we look at angle E right here, that's not a great color, so let's try something else. So if you look at angle E and angle O and angle T and R, they all have one swoosh mark. So we can write it actually in one long statement. So we can say that angle E is congruent to angle O, and angle O is also congruent to angle T, which is also congruent to angle R. And so when we make this long statement right there, that means every angle is congruent to all the other angles in that statement. That's a statement of congruence. Angle bisector. Okay, angle bisector, again like segment bisector, is a ray that divides an angle into two congruent segments. So if OU right here bisects this larger angle right here, KOR, then what that tells you is it tells you that this angle right here, which is KOU, will be congruent to this angle on the other side, which is angle UOR. So that is angle bisector. And again, if we put values on these, if we tell you that KOU is 41 degrees, then that also means that UOR is also 41 degrees. Pretty simple. And KOR, the larger angle, would just be 41 plus 41, or 82 degrees. And again, we get involved with more algebra type problems where we are having to simplify expressions, but it's really not too bad. Just pay attention and make sure you are reading the given information correctly. This particular one is saying that BD is bisecting this larger angle ABC. Okay, so we're bisecting angle ABC. So then what that means is, it means that this piece is congruent to this. So that means I would set 7x minus 19 equal to 4x plus 2. And now when I combine and move things around, I would subtract 4x, so I keep my x's positive, and add the 19 to the other side, which gives me 21. So x equals 7. So now they want me to find the larger angle right here. So I'm going to find the smaller angle first by plugging in my 7 to one of these halves. So 4 times 7 plus 2, that's 7 times 4 is 28 plus 2, that gives me 30 degrees. So this is 30 degrees, so the whole angle is 60 degrees. All right, so one of the things that gets confusing with segment addition and angle addition, and also just bisecting, is that sometimes students get confused whether they're supposed to set the two expressions equal to each other or add them together. So make sure you're understanding bisect means you're cutting it into two equal pieces. Segment addition just means the two pieces added together equal the whole. So try to keep those things straight. And that is the end